Hello students, welcome back. In the previous class, we were discussing the characteristics of a sound wave. Today, we are going to explore this topic more deeply. So, let's begin our journey into the world of sound waves. Whenever we hear a sound, what actually reaches our ears in a wave carrying energy? But how do we describe this wave? To understand any sound wave, we mainly need three important things. First, frequency. Second, amplitude. Third, speed of sound. Now, let's start with frequency. Imagine a guitar string vibrating. If the vibrates very fast, it produces a different sound compared to a string vibrating slowly. The number of vibrations or oscillation made by a source in 1 second is called frequency. One complete vibration is called one oscillation. In a sound wave, one compression and one rarefaction together complete one oscillation. Frequency is represented by F and its SI unit is Hertz. 1 Hertz means one vibration in 1 second. Now comes an interesting property, pitch. Pitch tells us whether a sound feels high or low. Pitch depends on frequency. A high frequency sound produces a high pitch, sharp sound. A low frequency sound produces a low pitched, deep sound. For example, the sound of a flute is generally high pitched, while a drum produces a low pitched sound. Now, let's understand time period. Frequency tells us how many vibrations happen in 1 second. Time period tells us how much time is needed to complete one vibration. It is represented by capital T. The relation between frequency and time period is T equal 1 by F. This means if frequency increases, time period decreases. Next, we have wavelength. A wave has different points like crest, throw, compression and rarefactions. The distance between two consecutive points having the same phase is called wavelength. It is represented by lambda. The distance between two consecutive crest, two consecutive throw or two consecutive compression is equal to one wavelength. The SI unit is meter. Now, let's talk about the speed of sound. Speed tells us how much distance a sound wave travels in a given time. We know speed equals distance upon time. During one complete oscillation, the wave travels one wavelength lambda and the time taken is the time period t. So, V equal lambda upon t, where V means velocity, lambda upon t means the time period. And because F is equal to 1 upon t, we get the important formula V equal F multiplied by lambda. This formula connects speed, frequency and wavelength. Let's apply this concept to a question. A person is listening to a sound of frequency 500 Hz. We have to find the three interval between two successive compression. The time interval between successive compression is equal to the time period. So, t is equal to 1 upon f, t is equal to 1 upon 500 means t is equal to 0.002 seconds. Therefore, the correct answer is 0.002 seconds. So students, today we learned that sound is not just something we hear, it is a wave with its own properties. Thank you for watching the video.